you're given limit x tending to 2, and you have 2x minus 7. Now, when you have a question like this, you use substitution methods to do it. So all you simply have to do is x is tending to 2. You plug 2 into x. So when you do it, you're going to have 2 in bracket 2 minus 7. So when you simplify it further, you're going to have 4 minus 7, which will give you what? Negative 3. So that will be the answer. Another example that involves substitution method. Let's say you are given a question of this x limit x tending to 0, and you have the values to be 3x squared plus 2x plus 1, okay, all in brackets. Now put this one in bracket. Okay, so very simple. All you have to do is x is tending to 0, so you plug 0 into this variable x. So when you do, you're going to have 3 in bracket 0 squared plus 2 in bracket 0 plus 1. So when you simplify further, you're going to have everything here I give you. So everything here, answer will be 1. So it's as simple as a factorization method. So let's look at a simple example of factorization method. You are given a question of this nature, limit x tending to 2, and you have x squared minus 4 over x minus 2. So how will you solve this question? Very simple, you factorize. So when you factorize the numerator, you factorize first before substitution. So to factorize the numerator, you're going to have x minus 2 x plus 2 over x minus 2. So this can cancel us. So once you cancel out, you can then plug in the 2 into this x, so which is 2 plus 2 equals 4. That's the answer. As simple as that, guys. So let's see one more example under factorization method. Let's say you are giving this value limit x tending to negative 2, and you have the values to be x squared minus 4 all over x squared minus x minus 6. Okay, so you factorize both the numerator and the denominator before you substitute. So when you factorize the numerator, you're going to have x minus 2, okay, x plus 2 all over. So when you factorize the denominator, you're going to have x plus 2 in brackets, okay, x minus 3. So this can cancel out. So once you do it, you'll be left with x minus 1, x minus 3. So you plug in negative 2 here respectively. So when you do it, you're going to have minus 2 minus 2, okay, over minus 2 minus 3. So you're going to have minus 4 over minus 5. So negative cancel each other. So the final answer will be 4 over 5. So it's as simple as that, guys. The hospital, what it talks about is differentiating the function before you substitute. So let's say we are giving this example, limit x tending to 2, and we have it to be x squared minus 4 over x minus 2. Okay, this question, though factorization can work on it, but you can also use the help tool to solve it. But it depends on anyone that works. Out of the 3 rules, one has to work on the question. There are sometimes 2 rules can, or 2 rules of it rather, can work on a particular question. So for this question, the help tool and factorization also work. So let's use the help tool and do it. So you differentiate both the numerator and the denominator. So when you differentiate the numerator, you're going to have 2x there. Okay, so over, when you differentiate x, you're going to have 1, right? So You then substitute these two into this x, substitute these two here into this x, so we're going to have 2. This, so the final answer will be 4. So it's as simple as that, guys. Same thing is applicable to this one we solved. Limit x tending to a negative number, so we have x squared minus 4 over x squared minus x minus 6. Okay, so this, when you differentiate the numerator, we're going to have 2x over, so this denominator, we're going to have 2x minus 1. So when you plug in -2 here and here, you're going to have 2 times -2 over 2 by -2 minus 1. So we're going to have -4 over -4. 2 times -2 -4 minus 1, I'm going to have -5. So you cancel everything, so answer 4 by 5. Okay, so we have limit x tending to pi, okay, tan x, this is tan x over sine 2x. Okay, so to simplify this, you have to, let's apply the help table to do it. So to differentiate tan x, you are going to have sec square x, you're going to have over, when you differentiate sine 2x, you're going to have 2 cos 2x. So we're going to have, so you break it down, the more sec is the same thing as 1 over cos, so sec square is the same thing as 1 over cos square x over 2 cos 2x. Now take notes of these notes. In trigonometry, cosec is the same thing as 1 over sine, then sec is the same thing as 1 over cos, cot is the same thing as 1 over tan. So very important to take note of this in case of solving problem involving 3 ratios. Okay, so having known that, let's keep simplifying this. So this will be equal as limit x tending to pi will be, so let's substitute, going to 1 over cos square pi over, but when you put pi in this x respectively, so you're going to over 2 cos 2 pi. Okay, so when you simplify this, the more, when I punch my calculator, you're going to have 1 over cos 2 pi. Okay, we'll give you minus 1. Okay, something that minus 1 square over 2. Cos 2 pi will give you 1. So when you break this down, the more, you're going to have 1 over 1 over 2. So which will be equal to 1 over 1 times 1 over 2. So our final answer will be half. So this is the basis of limits and introduction to limits of a function. And with this, we are coming to the end of the class. I hope you learned something interesting.